Hello, welcome to the second part of this series where I'll be showing you a method to solve limit and continuity questions. And this method I'll be showing in this video is the factorization plus direct substitution method. Now, if you've not watched the first video, which was solely on direct substitution, be sure to do that. All right. So in this video, I'll be showing you what happens when you get 0/0 after doing your direct substitution. So let's look at the first question. You have limit as x approaches 1 of x squared plus x minus 2 over x squared minus x. So let's try the direct substitution here. You're going to have 1 squared plus 1 minus 2 over 1 squared minus 1. So if you do this, you're going to get 1 squared is 1 plus 1 is 2. Then minus 2 is 0 over 1 squared is 1 minus 1 is 0. So you have 0/0. Now in mathematics, there are three types of quotients that involve 0. So you have 0 over a number, which gives you 0. You have a number over 0, which gives you undefined. And you have the case of 0/0. So the first two actually have a solution, an answer, but the third case means you need to do something extra. So let's do that extra thing in this question. And that extra thing we need to do is called factorization. So you need to check your function. Whatever is factorizable, just factorize it. Some things are going to cancel out, and you'll be able to get the answer to your question. So here, I'll write this as limit as x approaches 1. So x squared plus x minus 2, if you factorize that, you're going to get x plus 2 x minus 1 over x squared minus x. You factorize that, you're going to get x bracket x minus 1. So if you need me to make a video where I clearly explain, showing you the fastest way to factorize function, just type in the comment section factorization and I'll prioritize that video for you. All right, so getting back to this question, you see that x minus 1 cancels x minus 1 and you're left with limit as x approaches 1 of x plus 2 over x. Now you can go ahead and do your direct substitution. That's why this method is called factorization plus direct substitution. So you first of all factorize, then you attempt direct substitution again. Remember that direct substitution failed at the first attempt. All right. So if you substitute this, you're going to get 1 plus 2 over 1. So this gives you 3 over 1. So your answer is 3. So the limit for this function is 3. All right. So let's get to the second one. Now, in second question, this question is testing you on your understanding of difference of two squares, right? So, but you can try to substitute 5. You see that you're going to get 0/0, which is the problem we're trying to resolve using this method. So if you factorize this, you're going to get limit as x approaches 5 of x minus 5 over x plus 5 x minus 5. So here, x minus 5 cancels x minus 5. You're left with limit as x approaches 5 of 1 over x plus 5. So here you're going to have 1 over 5 plus 5, which is 1 over 10. So you found the answer to your limit. All right. Now in the third question, now this involves a square root function. It is not directly factorizable. Now I want to show you something new. It's called conjugation. All right. That's what we're going to be applying to solve this question. So what does conjugation mean? Conjugation simply means if you have a function a plus square root of b, take note that one part does not have a square root, just a real number, while the second part is a surd or it has a square root, right? So all you need to do to conjugate this particular expression is to change the sign between the whole number part. It could be a fraction or decimal, but you basically change the sign between the part without the square root and the part with the square root. So here the conjugate is going to be a minus square root b. So this is the conjugate. All right. So if I give you a question, for example, say 2 plus square root 3, the conjugate is going to be 2 minus square root 3. But take note, I've given some students questions where they fell into a trap. And the trap is when the part without the square root has a negative sign. For example, if I were to give a question minus 1 minus square root 5. So some students have produced responses like plus 1 minus square root 5. No, this is not the conjugate. You only get the conjugate if you change the sign between the part without the square root and the part that has a square root sign. So the conjugate for this function or expression is going to be minus 1 plus square root 5. This is the right way to get your conjugate. So that's what we'll be using to solve this question. So what we do is, after applying our conjugate and following the steps I'll show you, you will then be able to factorize and cancel out some things and get your answer. So let's get into it. So you can test to confirm that if you substitute 0 directly, you're going to get 0 over 0. So let's multiply by the conjugate. So the conjugate of this particular numerator is, so meanwhile, it's possible for the conjugate for the square root to be in the denominator. It doesn't matter whether it's numerator or denominator. It's the same thing. You just have to multiply the numerator and denominator by the conjugate. So the conjugate of this function is square root of x squared plus 100 plus 10. So this is the conjugate. So we multiply both the numerator and denominator by the conjugate. Okay, then plus 10. Now, to expand this, you need to understand difference of two squares in the reverse way now. Most times we use difference of two squares for factorization, but this time around we want to use difference of two squares for expansion. So here, you know that if you have your a square minus b squared is equal to a plus b, a times a minus b. So you notice that a is actually on the left side, a is actually being squared, then minus, then b being squared. So here we have a minus b, a plus b. So to expand the numerator, we just need to square the first one. So you have x squared plus 100 minus the square of the second one, which is 10 squared. So over x squared in bracket. Now, notice I did not expand the denominator. Don't expand it. Don't. If you do, you're in trouble. So don't expand the denominator. So here we're going to have square root of x squared plus 100, then plus 10. Okay, so simplifying this, there's a square here. So simplifying this, you're going to have x squared plus 100 minus 100 over x squared in bracket square root of x squared plus 100 then plus 10. Okay, so here 100 minus 100 is 0. So you're left with limit as x approaches 0 of x squared over x squared bracket square root of x squared plus 100 and plus 10. Okay, so s squared cancels s squared, so you're left with this limit as x approaches 0 of 1 over square root of x squared plus 100 then plus 10. So this is what you're left with. So if you can now go ahead and after any cancellation happens, you can now go ahead and substitute your limit value. So let's substitute x equal to 0. So we're going to have 1 over square root of 0 squared, which is 0 plus 100 and plus 10. Okay, so you have 1 over 0 plus 100 is 100, so square root of 100 is 10. 10 plus 10 is 20, so you have 1 over 20. This is your answer to this question. All right, so if you have square root function, first thing you should do is to apply the conjugation principle. And then you simplify just as I've shown you, and some cancellations will happen, and you'll be able to apply your direct substitution to get your answer. All right, let's do another question involving conjugation, and let's see if you understood what I explained in the previous one. So straightforward, you can try to substitute -3. You discover that you again get a case of 0/0. So without wasting any time, let's multiply both the numerator and denominator by the conjugate. So here we will have times 2 plus square root of x squared minus 5 over 2 plus square root of x squared minus 5. So applying the principle of difference of two squares for expansion, I'm going to have limit as x approaches -3. For then we're going to have 2 squared, then minus. We have the second part, which is square root of x squared minus 5 squared over. I'm going to have x plus 3 in bracket. Remember, don't expand the other part. The only part you expand is the part that involves difference of expansion of difference of two squared. All right. So you have x squared minus 5. Okay. So if you expand the numerator, if you simplify the numerator, you're going to have limit as x approaches -3, 4 minus. Now whenever the bracket is second one, don't ignore the bracket. So this square cancels the square root, so you're going to have bracket x squared minus 5 over, so you have x plus 3, and you have 2 plus square root of x squared minus 5. Okay, so let's simplify the numerator. So you're going to have limit as x approaches -3. So here we're going to have 4 minus x squared, and you're going to have plus 5 over, you have x plus 3, and you have 2 plus square root of x squared minus 5. Okay, so if you simplify this, you can get limit. So this will lead you to this led you to this. So this will give you a limit as x approaches -3 of 9 minus x squared over x plus 3, then 2 plus square root of x squared minus 5. Okay, so now you can see difference of two squares in your numerator. So you need to be very conversant with these concepts because you're going to recall several times. So 9 minus x squared can be written as this. We can factorize it into this. So limit as x approaches -3. So we're going to have 3 minus x, and we're going to have 3 plus x, right? Over x plus 3, then we have 2 plus square root x squared minus 5. Okay, so x plus 3 and 3 plus x mean the same thing, so they're going to both cancel. At the end of the day, something has cancelled out, so we can actually go ahead to substitute, to apply direct substitution after this step. So we're going to have limit as x approaches -3 of 3 minus x over 2 plus square root of x squared minus 5. So let's go ahead and substitute into this. So we're going to have 3 minus 3 over 2 plus square root of -3 squared minus 5. So this will give us 3 minus minus 3 is going to give us 3 plus 3, which is 6, over 2 plus, now -3 squared is 9, minus 5 is 4. So the square root of 4 is 2. So you have 2 plus 2. So here you have 6 over 4, which gives you 3 over 2. So your final answer is 3 over 2. I mean, this one was a long one because it involved conjugation, involves difference of two squares. So, but you see that it's actually a very straightforward method. Whenever you get 0/0 in your in your if your function or quotient involves square root, you just need to do your conjugation. Sometimes you be able to cancel directly. At other times, you might still need to do the difference of two squares before you're able to cancel. But after you've cancelled something, just go ahead and do your direct substitution. It's going to work. All right. Okay, let's go to the next question, question 5. So this is just to do a little more practice on what you have learned. So here we have two functions and they are factorizable. So we're not going the conjugation part again. All right. So we're doing factorization. So let's factorize numerator and denominator. So here we're going to have limit as y approaches -1. So if you factorize y squared plus 3y plus 2, you're going to get y plus 1, y plus 2. Okay? Again, if you need me to make a video for you showing you the best methods to um, to factorize your functions, just type in the comment section factorization. All right. So if you factorize the denominator, you're going to get y minus 2 y plus 1. So y plus 1 cancels. So you'll be left with limit as y approaches -1 of y plus 2 over y minus 2. So if you substitute into this, you're going to get -1 plus 2 over -1 minus 2. So this gives you 1 over -3, which is -1 over 3. So this is just it. Very easy to check out. So meanwhile, you can actually confirm that direct substitution from the onset is going to give you 0/0. All right. Always check that. But I mean, after watching my videos and after doing your own personal practice, you'll be able to identify quickly when you need to use factorization plus direct substitution instead of using solely direct substitution. All right, the final question in this video, um, limit as c approaches 2 of c cubed minus 8 over c raised to power 4 minus 16. So I intentionally brought this to challenge your understanding of factorization. So we have difference of 2 cubes and we have double difference of 2 squares. All right, so let's try this head on. So so you're going to have, if you factorize this, you're going to have c approaches 2. So difference of 2 cubed, c cubed minus 8 is going to be c minus 2. So you have to write it as c cubed minus 2 cubed. All right. And the rule is that if you have a cubed minus b cubed is going to give you a minus b bracket a squared plus ab plus b squared. So let's apply the same thing here. So you're going to have c minus 2, you're going to have c squared, then plus ab. So that's um, minus 2 times 2 times c rather. So that will be plus 2c, and then you're going to have plus 4. So 2 squared is 4. So this we're going to have over. Now, c raised to power 4 minus 16 can be written as double difference of 2 squares. So you're going to have c squared plus 4 and c squared minus 4. So this is what you're going to have. So you can break this part further. You can break it further down because that's the difference of 2 squares. So you're going to have c squared plus 4 bracket, then you're going to have c plus 2 and c minus 2. So if you factorize c squared minus 4, you're going to have c plus 2, c minus 2. So let's just write that here. So you're going to have c squared plus 4, you're going to have c plus 2, I'm going to have c minus 2. So c minus 2 cancels c minus 2. I have told you whenever anything cancels in this method, you're ready to get your answer. So here, so we're going to have limit as c approaches 2. So we'll have c squared plus 2c plus 4 over c squared plus 4 and c plus 2. So if we substitute into this, we're going to get 2 squared plus 2 bracket 2 plus 4 over 2 squared plus 4 then times 2 plus 2. So this will give you 2 squared is 4, 2 times 2 is 4. So you have 4 plus 4 plus 4. That's 12 over 2 squared is 4 plus 4 is 8. And you have 4 here. So 8 times 4 is 32. So if you simplify this, 4 goes here 3 times, 4 goes here 8 times. So your final answer is going to be 3 over 8. And that is it for this particular method. So whenever you have a question where direct solution gives you 0 over 0, the next method to try is the factorization or conjugation plus direct substitution, depending on whether you have normal functions or square root functions. So you choose either factorization or conjugation. But the next thing that follows that after something has cancelled out is your direct substitution. All right. So if you enjoyed this video, be sure to like and subscribe to this channel because there's another video in this series where I'll be showing you an entirely different method to handle 0 over 0 case in your limit and continuity questions. See you in the next video. Bye.